Good morning friends. In today's video, we are going to see how to study HVAC drawings for a luxurious high-rise building project like shown here. Additionally, based on my experience in Qatar, UAE and Saudi projects, I am going to add some of the mistakes which we normally do in site installation and estimation also. So if you are looking for jobs in Middle East or if you want to get some clear idea about HVAC installation, don't skip this video till the end. Let's start the video. The very first step in the project review is you have to see the single line diagram to understand what are the systems we have in this project. So first of all, coming to the building structure, so we have the two basement like I show here. We have the second basement and first basement, then we have the ground floor, then we will go up to see how many number of floors we have in this project. So total we have till 6th floor level, then we have on roof floor level and top of the roof. So top of the roof we can see the FAHU unit here. FAHU with the ERU, so FAHU with the heat recovery wheel is there for this unit, and the remaining for all the floors we can see the fan coil unit. So fan coil unit is connected with the district, the piping line is there. So we have to we couldn't see any chiller like air cooled chiller, water cooled chiller, nothing is there in the project. So we can almost finalize that this project we have the district cooling system. So like you see in the ground floor, so we have the ETS room. So somewhere the pipeline is coming from outside. From here we have the ETS room. ETS room we have the heat exchanger and other accessories. And from here the line is going. So let's go to the ETS room to see this one. When coming to the HVAC drawing, normally we can make the HVAC drawing like two type. We can like for example, you can see the air side and the water side. So coming to the water side first, we have two arrangement. One is the chilled water system, another one is the district cooling system. In the chilled water system, we normally have the air cooled chiller, water cooled chiller with the cooling tower, this type of arrangement. Coming to the district cooling system, we have the normal, we have the common central plant, and there we have the pumps and other items are there. From there, the pipeline will go to different area like this. So here there are different apartments will be located. So there will be different apartments and villas will be there. So from here we can make the tape of connection, and this connection will be serving to our villa or apartment. So this connection normally we call as a district cooling system. There will be some common district cooling distributor will be there. So like we can say, if you go to Qatar, we have the Qatar Cool, and if you go to UAE, we have the EMI Cool. Like different things are there. So they are the operating person for this district cooling system. And coming to the air side, you can see that this air side normally we have the major cooling supply system like AHU, FCU, FAHU, package units, VRF, and different things will be there. Coming to the cooling supply side, and we also have the air side exhaust ventilation like toilet ventilation, kitchen ventilation, this type of thing. And also we can see the other ventilation like a generator room ventilation, pump room ventilation. So this type of other ventilation also will be part of the air side HVAC drawings. And fourth one, you can see the smoke pressurization for the staircase or stairwell, or you can go for the lift pressurization, corridor pressurization. So this type of air side and water side, we have this much drawings we have to see coming to the HVAC drawings. So the single line diagram which we referred to now is very clear that belongs to the district cooling system, because we couldn't find any air cooled chiller and water cooled chiller. So we'll proceed with the same district cooling system for this drawing review. So here you can see the ETS room. ETS room is called as Energy Transfer Station, or sometimes we will call as a HEX building. HEX building means heat exchanger building, or sometimes it is called as a chilled water pump room. So here you can see the pipeline is coming from the outside, and here it is shown like a 2A. So TA means is a 2 above. So from here the pipeline will be underground buried pipeline. It is underground. It is passing through the trenches, and from here the pipeline is going to the above ground. So there is a difference between the underground and above ground piping material. For example, for the underground application, like you see in this picture, we are using the pre-insulated pipeline. That means the inside pipeline, like you see here, this is the carbon steel pipeline, and after that we have the polyurethane foam insulation. After that we have the HDP jacket. So this three arrangement will come in the underground buried pipeline called as a pre-insulated pipeline. So coming to the material grade, what we normally use is ASTM A53 grade B, and the thickness is schedule 40, or ASTM A106 grade B schedule 40. So these two are the mostly used material in the Middle East countries, and this is common for both the underground and the above ground. So for the underground, as I mentioned, is a pre-insulated pipeline which is coming from the manufacturer itself, insulated, but for the above ground application we are using the post-insulation pipelines. Like you see in this image, this is the pre-insulated pipeline which is laid down in the underground trenches. So like you see here, the welding is happening here. After the welding, like you see in the left side image, we will do the site insulation over the welding. After the testing of the welding, we will do the site insulation. After that, it will be covered with the HDP jacket, same like what we did here. The same will be happening at this place. So this is called as the underground chilled water pipelines. So here, as I explained, this pipeline from the underground line which is coming from outside and which is coming to the ETS room. So when coming to the tie-in connection with the existing, you must consider two important cases. So the first case is, for example, your ETS, your central plant is located somewhere here. From here, the line is passing through different areas. For example, your apartment is located at this point. So here we consider two cases. The case one is, for example, when the underground people develop the pipeline, for example, what they will do for the future connection, they will provide the connection like this, and here there will be some wall chamber will come. So when you go for the building construction, we will take the connection only from the after the wall chamber. So already there will be wall will be there. So there is a branch line and a wall. So this is very easy to make the tie-in connection, because after the wall there is no pipeline. You will simply bring your pipeline and you will connect with the wall chamber, inside the wall chamber, after the wall pipeline. So in this case, there is no need of shutdown of any system. You can simply make the tie-in connection. Now coming to the case 2. In the case 2, the very important case is, again same, we have the central plant and the existing line is going like this, and here is our apartment, and we have to make the connection for the ETS room till the existing line. So in this case, what happened, this is the running ongoing live connection, and you have to make the tie-in connection with the ongoing live connection, because this chilled water is, this district cooling system is supplying the water to different apartments and different villas. So only for your apartments or your villa, they cannot shut down the system. So you have to make the tie-in connection in a special method called as a hot tapping method. So like you see here, this is the two existing line which is going in this one. This is the supply and return line. So we will get the permit from the operator only for to open that side area, and also we will remove the insulation from, like you see here, we will remove the insulation in both the supply and return line, and the other side we will bring our line. Like you can see here, there are two. This line is a supply and this is the return line. So both line we will bring from our side to make the connection. In this case, the operator cannot make any shutdown. They cannot give any shutdown permit for you to make the connection, because this is connecting with the different apartments. In this case, what happened, in the hot tapping method, the connection is done in the live pipeline. So the water is passing, and meantime we will make the connection. So this is called as a hot tapping. The hot tapping valves, like you see here, which is not, this is not the normal valve. This is 10 times expensive than the normal valves. So when you go for the estimation, you have to make sure that if your operator is telling the permit is not given for the setup bit, then you have to go for the hot tapping. Hot tapping is very expensive, and even the hot tapping valves are very expensive. So like you see here, this is the machine. So this machine, it will rotate and it will penetrate into the pipeline. So after the penetration, it will remove the cut piece. So like you see here, this is the cut piece from the pipeline. So some of the operator will ask this cut piece, because by mistake this cut piece should not go into the pipeline. This will make some impact. So the operator will ask, where is the cut piece after the end of your operation. So you have to show this type of cut piece also. This is how the hot tapping is done for the tie-in connection. So after the tie-in connection, from here, the two pipelines, supply and return line, will be taken into the ETS room. So like I showed here, you can see the pipeline which is coming from the outside, which is going inside, and from here to above, this becomes the post-insulated pipeline, that means the above ground pipeline. So in the ETS room, we can make the connection like two type. One is the primary side and another one is the secondary side. Like you see in this supply connection, for example, from here we have two connections. One is going to this heat exchanger, and another supply connection is going to this heat exchanger. And after coming to the return, this supply will go to the top, and from here the return will happen. So this is one return and this is another return. So both this return will merge at this point, and this will go to the again the operator side. So the connection till this point normally we call as a primary side, and after this connection this is called as a secondary side. In most of the projects in the Middle East, normally this primary side will be done by the operator recommended contractor, and coming to the building side, I mean the secondary side, this is normally done by the building contractor, and some project the operator will recommend to allocate the building contractor to do the primary and secondary also. So we have to make sure that what is our exact scope of works. In the ETS room, the first important items we have to see is like a heat exchanger. Then we have the pumps, chilled water pumps. Then we have the air separator. We have the expansion tank. Then we have the chemical dosing tanks. And additionally, when coming to the instrumentation side, you can see the things like temperature transmitter. Like you see here, pressure differential transmitter and temperature transmitter, and this type of thing will come. So I will create a very detailed separate video only to study about the ETS room, including the instrumentation and the mechanical item, the flow meter, motorist valve, everything, including the BOQ estimation purpose also, and also installation, because this is a very big topic we cannot cover in a single video. So like you see here, we have 2 heat exchanger and 3 pumps. So we'll go to the heat exchanger schedule to see what is the capacity of the heat exchanger. So like you see here, this is the heat exchanger 1, that is the tag number, heat exchanger 1. So we have 2 quantity, and here they clearly mention that 2 duty PHE. So that is a PHE means plate heat exchanger, and there is 0 standby, there is no standby here, and the total heat exchange is given in kilowatt per each. So here we can convert this kilowatt to ton of refrigeration. For example, 1 ton is equal to 3.517 kilowatt. So we can say here 389. You can say like 389 divided by 3.517. 110.82 ton of refrigeration. So we have two heat exchanger with 110.8 ton. So like I show here, and the second very important thing is district cooling water side in and out. So this district cooling water side, what they are telling 5 and 14 degree. For example, if you go to this ETS room, so here the incoming line, this is 5 degree, and the outgoing line, this is 14 degree Celsius. So if you convert this one in the Fahrenheit, for example, it is 5 degree Celsius, you can say it is 41 Fahrenheit, and 14 degree Celsius, it is 57.2 Fahrenheit will come. So like you see here, primary side we have 5 degrees Celsius, I converted to Fahrenheit, and secondary side also. If you make the delta T in Fahrenheit, it will come like a 16 degree Fahrenheit. Similarly, if you go to secondary side, the secondary side you can see, that means the customer side or the building contractor side, it is 15.2 and 6.2. So that means the 6.2 line which is supplying to the building, and the return it is coming like 15.2. So if you convert the same thing like what we did in the earlier one, for example 6.2 is equal to 43.16 and 15.2 is equal to 59.36. So the overall delta T is with 16 degree Fahrenheit. So for the primary side and secondary side, the delta T is constant like 16 degree Fahrenheit. Normally for the distribution system, this delta T always will go like a 16 degree Fahrenheit, in that range, based on my experience in Qatar and UAE also. After that, the water flow rate also given for the heat exchanger 10.28 liter per second. So this will normally match with the pump. For example, if you see here the chilled water pump, so here we have given N section top discharge centrifugal type of pump. So total 3 is given. That means very clear that 2 duty, because here we have 2 heat exchanger. So 2 duty and 1 standby pump will come here. And coming to the water flow, this will match with the heat exchanger flow. And the head value they have given, the pressure head is 40 meter. But as usual that this head is not not the always not a fixed one, because they will mention very clearly here, this head must be verified during the execution stage after you prepare the sub drawing. Before you go for the order of the pump, we must verify the head with the actual fittings and pipe routing. So this is not the final one, and the tender stage we can confirm with this one, but when you go for the execution, you have to redo the pressure head calculation. So here in our project, as I told, the outer line is coming from here. We have inside heat exchanger and the chilled water pumps. After that, this supply line connection, like you see here. So one line from here, which is going to the bottom to supply to 2 basements, second and first basement. And from here, we have 2 riser, one riser here and another riser here. So this line will supply to all the remaining floors from ground floor to 6th floor. And at the top of the roof, we have the FAH also. So like you see here, for example, at this level, from here we have the tapping of the connection from the main riser, both the supply and return connection. So this is supplying to different FCUs like shown here. Similarly, for all the floor level also, we have the distributed connection connecting with the fan coil unit. So here one important thing you can note down. For example, here you can see this is the taping connection which is going to supply to all the FCU. And for this FCU, the first basement in the storeroom, the flow rate which is given for this FCU is only 0.09 liter per second. That is very low amount. But still the minimum pipeline for the overall project, the designer has considered to keep 20 mm pipeline, because this is important thing, because some project for this very flow rate the designer will go less than this also. For example, instead of 20 mm they will select the minimum pipe size also 15 mm also. So in this project they have considered the minimum pipe size, even though the flow is very low like 0.09 liter per second, the minimum pipe size they have considered like 20 mm. Normally this is my regular practice also. I will consider minimum pipeline as a 20 mm. And in the FCU supply line, the important thing as you see here, we have one wall connection that is called as a PICV wall package. So this is the PICV wall package standard details. Like you see here is the flow direction, that means the supply connection. Also you can identify the supply connection by seeing the item called as a strainer. So if you have the strainer somewhere, that is called as a supply to some equipment. And here we have 3 isolation wall, 1, 2 and 3 isolation wall, and we have the drain connection and we have the strainer here. So there will be a connector, like a union connector will be there, and we have the flexible connector also to connect with the equipment here. And also in the return side, same the flexible arrangement. Then we have here the PICV wall, like you mentioned here, we have the pressure independent control wall. After that the isolation wall, and this line will go to the system. So here one important thing you have to note down, that this PICV wall package comes like a full package if the pipe size is very low. For example, normally in the Middle East the pipe size is like 15 mm, 20 mm, 25 till the 32 mm, we will get the things like a full package. But if the pipe size is very high, for example if you are supplying the connection to the FAHU and AHU where the pipe size is normally very high like 40 mm, 50 mm, 65 mm, you cannot get like a full valve package like I shown here. You cannot get like this type of full valve package. That time you have to go for the individual connection. That means the strainer you have to purchase separately, the isolation wall you have to purchase separately. Like the individual connection will come, the price also will get increased if you go with the individual connection. So like we saw in the schematic diagram, we have the fan coil unit. So here the schedule for the fan coil unit. So we have total 8 type of schedule, 8 type of FCU we have for this project, and you can see the quantity, different quantity we have given. So first is the first one is the airflow, which is given in the liter per second. So there are different airflow they have given. The next important thing is the ESP, or we can say normally external static pressure. So here they have mentioned external static pressure to be verified by the contractor, providing calculation report prior to equipment selection. So before you go for the any material order like FCU, AHU, FAHU package unit, you must submit the external static pressure calculation to the consultant for the approval. Then only you can go for the procurement. But normally what happens when I go for particularly IFC drawing, I will not do that much calculation, because as they mentioned here, we have to give this type of responsibility to the contractor based on the duct routing. I mean the actual duct routing, the contractor will develop the external static pressure calculation. So what normally I do is, so for example, I will keep the default value. For example, if it is the fan coil unit, normally 1 inch of water is equal to 250 Pascal. So when I go for the calculation, the details like IFC stage, I will keep for the FCU like 50 Pascal. This is my default value. If we have the small duct routing, if I see like the duct routing is very big, I will simply increase to 75 Pascal. And when it comes to package unit, I normally keep like 250 Pascal. And when coming to AHU or FAHU, if it is a small duct routing, I keep 500 Pascal, or if it seems like a very big routing, then I will keep like 1000 Pascal. And like shown in this drawing, I will also mention that conductor again re-verify with the actual duct routing. So this is what this design also they have done, like a small duct routing 50 Pascal, for the big duct routing 75 Pascal he has kept for the FCU. So let's recheck one time for the FAHU, how much he put for the designer has put for the FAHU. So here you can see the FAHU schedule, and here they have considered the external static pressure like 1000 Pascal. So maybe the duct routing may be very high. Like you see in the single line diagram, we have only one FAHU which is in the roof, so surely the duct routing is very high. So he has considered the highest static pressure value. The duct routing is normal, we don't need to go with that much thing. In the IFC drawing, we can keep 500 Pascal for the AHU and FAHU as I mentioned. After that the contractor will verify the actual one. So once the ESP is finished, external static pressure is finished, the next important thing is the total cooling load and the sensible cooling load. Both the unit they have given in the kilowatt. This is one of the important item normally I consider for the selection. Like normally for me, the selection will be based on the airflow and sensible cooling load and the on-coil off-coil temperature. And I have posted a very detailed video about this the different terms, like how to verify the total cooling load, sensible cooling load, and I have given the link in the description. Please have a look at that. And after the total cooling load and sensible cooling load, we have to see the important things like temperature. So here the TWI is the incoming temperature and TWO is the outlet temperature. So incoming temperature to the FCU 6.5 and outlet temperature is 15.5. So when you go for the selection, you have to inform, you have to give this schedule to the manufacturer. He will match this temperature for the FCU unit. And the next important thing is the water flow. They have given in the liter per second. So this also we have to match, we have to consider when go for the selection. And the connection size in and out. So for the FCU, the connection incoming and outgoing size they have given very clearly here, 20 mm pipeline. And for the drain connection also, the CDP, condensate drain pipe connection also given, 20 mm pipe we have to follow for this FCU. And when you go for the FCU at the time of selection or the tender time, you have to give a very important thing for this item. So that is what I normally consider, like all units shall be provided with the double skin casing they have given. Normally we have single skin casing, double skin casing. So there are two types like this, single and double skin. So what is the difference is, for example, if you are installing the unit in some high class villa, and if you want to avoid the noise, normally we can go with the double skin insulation. And if you are going with the outside, for example the pump room is there, and if you are supplying the FCU for the pump room, so that time this noise is not an issue, so you can go with the single skin casing. So the price difference is there for both the item. You have to make sure when you go for the tendering time whether it is a single skin or double skin casing. And the second important thing, all the airflow rate when you go for the selection, you have to match with the medium speed, because normally there will be three type of speed will come: low speed, medium speed and high speed. So here they have given all the selection will be based on the medium speed, so you have to make sure this point. And the third very important thing, normally I always see the first point, what type of motor we have to follow, whether it's like a AC motor or we have to follow the EC motor. So the EC motor is an expensive one, it's not like AC. EC means electronically communicated motor. The very first point when I go for the FCU project specification is, I will see this point only, whether it's a AC motor or EC motor, which one I have to choose. So please keep in mind this type of important point for the FCU selection. And here is the overall layout of your 6th floor. So let me just open, let me just zoom one item. For example, here you can see this FCU is supplying the air to the bedroom, and here I have shown only the water side. As I mentioned, the air side I will post in the separate video, because that one we need a very detailed analysis again. So here in the FCU, when you go for the FCU location, the first important thing you have to see, because in the bedroom there should not be any noise. So it's always recommended to keep the FCU inside the bathroom, and because if you want to do some maintenance, that time also it will not disturb the people inside the bedroom. You can simply do the maintenance in the bathroom. So that's why most of the engineers, like shown here, they will keep the FCU in the toilet room. And when you keep the unit in the toilet room, just make sure that you have sufficient space in the all the side to access the FCU, because normally for the FCU filter cleaning, for example, let's say the filter is in the back side, you have to open and clean randomly. So you have to provide the access panel in the for the FCU. Normally this access panel, in the normal case, it will be 600 by 600 mm access panel we will provide. If you don't have sufficient space because of some other reason, at least provide 450 by 450 mm access panel. So you have to make sure that you have sufficient space in the back side also to provide the for the maintenance purpose. So this is the first case we have to consider. And the second important thing is, sometime in your project, if you have the electrical service room, like IT room, server room, as per the local, means the usual practice in Middle East is like you must provide the standby unit. So here in our project, the overall system we have is the district cooling system. So the standby unit also, you cannot make the connection with the district cooling system. For example, let's say that we have an electrical room here. So your district cooling connection supply and return line is passing. So you can provide only FCU with this supply and return line. This will serve serve as a duty system for this server room. And coming to the standby system, you can provide the DX pretty read, I mean the standalone system. For example, the outdoor you can place somewhere. From here you can take the refrigerant pipe, you can keep the indoor pipe. So this will be acting like a standby unit. So this type of duty standby combination we must provide when it comes to electrical service room like IT room, server room, this type of thing. And second thing, if the FCU is located sometime inside the room, for example there is a IT room, if the FCU is located inside the IT room, you must provide the drip tray. So the drip tray must be provided because the falling of water inside the item will make some serious impact. So you must provide the drip tray below the FCU. From there this will connect with the nearest drain. Like if it is the bathroom, then this will be nearest flow drain connection we can provide. So in this case, normally what happens? So inside the room we will provide the drip tray. After that the drainage pipe will go like this. For example, if you have the bathroom here, the drainage pipe will go like this through the ceiling, and here through the wall it will go down, and this will connect with the flow drain. And coming to the pipeline for the chilled water and this thing, for example here what they have mentioned in this project, chilled water piping 5-inch dia and less than that one, we have to use the black steel seamless piping. So there are two important things, seamless piping and welded piping we normally call as a ERW, electric resistant welded or seamless piping. So in this project they inform that less than 5-inch pipe, 5-inch and less than that one, we have to use the seamless piping without any welding in the pipeline. Means the pipeline has to come without welding from the manufacturer. And after that 6-inch and above we have to use the ERW or welded pipeline schedule 40 also. So this will vary normally. This is not a rule in the ASHRAE and any other book. You have to use the seamless or welded pipe. Based on the project to project it will vary. You have to verify whether your client is asking you to use the ERW pipe or seamless pipe. And coming to the fittings, so here you can see 50 mm dia, and under that you can use the carbon steel pipe, the screwed one. So this is very important. And coming to the fittings, over 50 mm you can use the steel pipe, same carbon steel but butt welding pipe. So this is a two difference. So less than 50 mm screwed one, above 50 mm you have to use the butt welding pipe. And coming to the condenser drain pipe, UPVC high pressure pipe you have to use, and mostly in the Middle East, based on my experience in Qatar and Saudi and UAE, for the UPVC high pressure pipe we are normally using the class E pipeline, that is a 15 bar pipeline. The standard is BS3505. This is mostly used in some project. There will be some American standard also. For the British standard mean BS3505 class E pipeline, that is a 15 bar pressure pipeline we are normally using for the condenser drain pipe. So that is not exposed to view. That means if it is the buried line you can use the UPVC. If it is the exposed line you can use the GI pipe for the exposed condenser drain piping. And next in our project, as I mentioned earlier, we have one FAHU in the roof. So here you can see the tag number FAHU1. We have one FAHU, and this is supplying to all the apartment as for the fresh air supply, which is located in the roof. And the air capacity or the fresh air capacity, that means we have the FAHU. We are taking 100% fresh air from the outside, and which is going to supply to the room. And here they have given air capacity 2797 liter per second. So this much fresh air is taken here. And coming to the external static pressure, as I mentioned, if the ducted routing is very high, you can normally mention 1000 Pascal in the IFC drawing. And here there are some electrical parts like motor voltage, and this one is given voltage, phase, and frequency they have given. This frequency is very important because this frequency 50 Hz is not common for all the Middle East countries. This is very one of the important thing, because if you go to Qatar, UAE, the 50 frequency we will use, but if you go to Saudi Arabia, the frequency is not 50 Hz, it is 60 Hz. So the thing we have to consider very important thing, very importantly. And second thing, total capacity and sensible capacity they have given the kilowatt. It's very easy to verify whether it is correct or not. You can watch that my previous video, which I have given the link in the description. And the degree Celsius, you can see 6.5 and 15.5. This is same like the FCU which you used in the FCU also. So the same one we have given here. And here next one, here also you can see 6.5, 15.5, and FC also we use the same one. So all the equipment will come the same temperature we will follow. And coming to the water flow rate, here they have given 3.7 liter per second. This is very easy to verify this one. I have given the explanation in the chilled water pipe sizing also, but still for easily we can review this one. For example, here they have given like 140 kilowatt. So 140 kilowatt divided by 3.517. So we are getting 39.8 ton. So first we have to convert to ton, and we have to multiply with the constant value of 24 divided by the temperature delta T. So delta T in our case, so earlier also I mentioned this one, the delta T we are normally following 60 degree Fahrenheit here. So the 16 degree Fahrenheit we have to divide with the answer, that means by 16. You will get 59.7 GPM. So GPM normally we can convert to liter per second. For example, 15.8 it will come. So 3.7 liter per second is the water flow. So for example, if you go to the schedule also, 3.7 liter per second. So that is the supply flow. This is how we normally verify that one also. In between the video, I have a small request for you. I would like to post more and more technical videos because all the people cannot join in my paid online training classes also. I'm really happy that you people watch the video, but please subscribe also because this will encourage me to post more videos for you. So thank you. And coming to the next important thing, for example, you can see this two FCU. This is a supply connection for this FCU, and this is a supply connection for this FCU also. Here you can see the coil side. For example, this coil is located in the left side connection to the FCU, and coming to this FCU, this coil is located to the right side connection to the FCU. So when you go for the big order like 700, 800 FCU for your project, you must focus on each and every FCU coil side. For example, in the left, in this video, sorry, this FCU, the coil is in the left side, but this FCU, this coil is in the right side. If you order all the 700, 800 FCU for a big project like a same coil side, all the FCU in the left side coil side, what will happen? For example, if you order in this FCU the left side constant coil, in this case we have to take like this the pipe, we have to go like this, we have to go like this, again we have to go like this. So unnecessarily I have to add this much number of additional fittings and unnecessary pipeline instruction in the back side to assess the filter. We have no issue. We can inform the manufacturer that instead of keeping the filter in the back side, we can keep the filter in the bottom of the FCU also for the easy access. So you have to be again careful when you go for the selection of the FCU. Due to more information in the HVAC drawings, I plan to post the videos in different parts, including the ETS in a separate video, the HVAC ad set in a separate video. So in continuation of this video, in the part 2 video, we'll continue with the chilled water pipes installation and what are the problems normally we face in the installation, some other mistakes and the practical issues in the Middle East experience. So all we will discuss in the continuation of this video. Thank you for watching the video. Please don't forget to subscribe the channel. Thank you. Bye bye.